What are the domain and range of a function? The domain of a function f is the set of all possible input values that the function can accept. Remember that the input values are the independent variable on the first, or horizontal, axis. The domain of f is written as df. The range of a function f is the set of all possible output values. Remember that the output values are the dependent variable on the second, or vertical, axis. These values are determined by the input values from the domain. The range of f is written as Rf. Let's get a better understanding of this through some examples. You will find the domain and range by studying the graph of the function and the function's expression. Be aware that there are different methods for finding the domain and range depending on the function. You will learn more about these methods at a later stage. Say you have the function f of x equals 1 over x. Here you see the function's graph. You study the graph and notice how it splits into two branches around the origin, x equals 0 and y equals 0. What's going on here? Well, f of x is a fraction, where x is in the denominator. To find the domain of f, df, you need to find the x values that actually give a y value. Fractions can't have a denominator of 0. So x equals 0 can't be a part of the domain. This is why the graph does not intersect the y-axis. And why the graph splits into two branches around x equals 0. For all other positive and negative x values, the function has a defined y value. So the domain of the function f of x equals 1 over x is all of r except 0. You write it like this. The big R is a way to refer to the set of all real numbers. Next, you want to find the range of f, known as Rf. First, let's take a closer look at the area around x equals 0. On the left side, where x is negative, you notice that the graph extends far downward along the y-axis. Here, the function gets large negative values. This happens right as x becomes a very small negative number, close to 0. The reason is that as you divide 1 by a super small negative number, you get a super large negative number in return. On the right-hand side, where x is positive, you notice that the graph extends far upwards along the y-axis. Here, the function gets large positive y values. This happens as x is a positive small number, again, close to 0. That's because as you divide 1 by a super small positive number, you get a positive super large number in return. So you know the range covers large negative and positive values. But what about the small y values? Well, study the area around the x-axis, where y equals 0. Look at the sections where the x values are large. When you divide 1 by a super large number, positive or negative, you get a super small number, positive or negative, in return. So the super small positive and negative y values are also part of the range Rf. But what about y equals 0? It turns out there is no x value you can input into the function 1 over x and get 0 as an answer. You can get answers super close to 0 when x is extremely large, but never exactly 0. So the range of the function f of x equals 1 over x is all of r without 0. You write it like this. Now let's consider a different example. Say you have the function g of x equals 2x. Here you see part of the function's graph. you study the graph g of x equals 2x to find its domain and range. The graph extends far in both directions as you scroll along either axis. You find no gaps or breaks in it no matter how far you zoom out or in. The function g of x multiplies all x values by 2. There is no number on the number line that can't be multiplied by 2. So the domain of g, dg, is the set of all real numbers, written like this. The same goes for the range. Inputting any x value will give you a unique y value. This is why the graph of g does not have any gaps or breaks. So in this case, the range is the whole of R as well, and you write it like this. This type of function, g of x equals 2, is called a linear function. As mentioned earlier, you will learn a lot more about the domain and range for different types of functions at a later stage. For now, it's especially important to take note of how the domain is connected to a function's x values and the range is connected to its y values. The domain of a function f is the set of all possible input values that the function can accept. Remember that the input values are the independent variable on the first, or horizontal, axis. The domain of f is written as df. The range of a function f is the set of all possible output values. Remember that the output values are the dependent variable on the second, or vertical, axis. These values are determined by the input values from the domain. The range of f is written as Rf.